G'day guys and welcome back to the channel. So today's video is going to be all about automatic transmission lockup kits. So in today's video we're going to learn about what an automatic transmission lockup kit is, how they work, briefly about how an automatic transmission in a modern day diesel works, why we fit them to our car, and stay tuned to the end and we're going to go through some testing runs side by side and to see how effective these units really are and see whether they're worth fitting to your four-wheel drive. So stay tuned and let's get straight into today's video. So what is an automatic transmission lockup kit? So a lockup kit is an electronic module that we place into the car to create a solid drive line from the crankshaft of the engine straight through to the gearbox of the vehicle. Now the way in which they work is that module takes control of the factory car's solenoid that controls the automatic torque converter within the vehicle, and it causes it to lock up at certain speeds or user-defined actions. Okay, so in order to understand why we fit these units to our car and how they work, we need to have a brief understanding about how an automatic transmission works and the role that the torque converter plays in that system. So a torque converter is a fluid style coupling that transfers rotating power from an input to a load. Now, in an example of this Landcruiser 200 series here, the input would be the engine and the load being the gearbox. So there's a small impeller on the engine side of the torque converter which turns with the rate of the engine. On the receiving end is an impeller which is connected to the gearbox, and in between that is a fluid which is your gearbox oil that transfers the power from the engine to that gearbox. So the equivalent in a manual vehicle would just be a standard clutch, and this torque converter is what prevents the vehicle from stalling when the vehicle is stationary but you're in a forward drive or reverse gear. It also provides a nice smooth power band up until those higher speeds where the transmission will lock from factory. So the main characteristics of a torque converter is the ability to multiply torque when there is a significant difference between that of the input and the load. So there are three operational phases of a torque converter. The first one is the stall phase. So this is when there is an input, however there is no load or the load is stationary. So an example of this in the Cruiser would be when the engine is idling in drive gear, however the vehicle is stationary. The second phase is the acceleration phase. So this is when there is a turning motion in the load, however the differences between the input and the load are significant. So for the vehicle this would be during acceleration when the engine is revving up, however the vehicle is still taking off. So the third phase is the coupling phase, and this is when the speeds of the gearbox and the engine are relatively similar, and this is generally where factory lockup occurs. Now the reason gearboxes have a lockup is to do two things. First of all, reduce the temperatures of the automatic transmission fluid, and the second one is to reduce fuel consumption. So the fitment of an aftermarket lockup kit simply alters where and when the lockup of that transmission occurs and determines how long the transmission stays in locked position for. So you might be thinking, if I need to add a lockup kit to the vehicle, why didn't Toyota just add it in the first place when it left the factory? Now Toyota specifically designed this vehicle and the way in which the gearbox behaves for the way the vehicle left the factory. Now on this particular vehicle, and what's very popular in Australia, is adding a lot of aftermarket modifications, increasing tyre size and often towing heavy loads. So this vehicle in particular weighs close to 3.5 tonne. We're running 34-inch tyres which are wider and obviously taller, and we do often tow a 2.5 tonne caravan. Now this has a significant effect on the way in which the engine, the gearbox and the vehicle manages how the power from the engine is applied to the wheels. Now this does also throw out the coupling effect of that torque converter stage, and therefore keeps it in the acceleration effect, in the acceleration phase of that torque converter for more often and for longer periods of time. Now what this does is it generates a lot of heat throughout the gearbox, specifically in the torque converter itself, and does also increase the fuel consumption of the vehicle. Having an aftermarket lockup kit is going to be very valuable in providing an accurate input through the accelerator pedal in the vehicle. It's going to change the way the car performs and also the way in which we can control the vehicle and the way in which the power is manages to get to those wheels. So the first advantage is off-road situations. Having a direct connection to that drivetrain is going to give us predictable and accurate acceleration, but it's also going to significantly improve the way in which the vehicle handles during deceleration. Now, automatic transmissions are generally known to not have very good compression braking through the engine. However, directing that driveline to be locked at low speeds and during deceleration is something that an automatic transmission doesn't normally do from factory. It's going to provide accurate and efficient deceleration compression braking through the engine. Now it's also going to significantly improve the fuel consumption, as there's no power loss through the torque converter in the form of heat as that fluid coupling is spinning. Having that direct connection is also going to significantly lower the torque converter temperatures and therefore the automatic transmission fluids as a whole. Now this for me is probably the biggest benefit you're going to get out of this particular kit, as we do tow a 2.5 ton caravan, and having the transmission unlocked at highway speeds when towing that van significantly increases the temperatures of the torque converter and therefore the automatic transmission pan over time as a whole. Some of you may know that in these Toyota Landcruiser 200 series that Toyota claim that the gearbox oil in this vehicle is good for the life of the vehicle. Now again, that particular claim was made from the vehicle coming out of factory and the way in which it was designed and behaved from that factory position. Having this vehicle modified and used in heavy off-road situations towing heavy loads, the oil there is going to be getting extremely hot without one of these lockup kits. There's no way it's going to last the life of the vehicle if it's used in those types of heavy duty situations. So every time the transmission fluid in the torque converter or in the transmission gets too hot or overheats, it's going to reduce the way in which it can cool and lubricate that gearbox. Now over time this is going to cause damage, and it's also going to cause the gearbox to behave poorly. So in essence, the higher the temperature of that oil and the longer it stays at those high temperatures, the shorter the oil life is going to be. And just to give you an example of this particular Landcruiser 200 series. Now, like I said, I do tow a 2.5 ton caravan, and coming back from a recent trip down south, just on the highway, I was getting an extended periods of time where I could not get the transmission to lock in at any speed I was driving legally. Now this caused the torque converter temperatures to increase and then drag the pan temperatures up to come with it. Now at that time I was getting transmission torque converter temperatures of up to 130 degrees and the pan temperature was up to 110 degrees. Now although that is still in operating temperature, having the transmission fluid remain at those sorts of temperatures for an extended period of time is going to significantly shorten the life of the oil and the way in which it lubricates and cools the transmission during operation. So moving on to the lockup kit that I installed into my cruiser. So for this particular vehicle I chose the Stocklock Extreme lockup kit, and there's no particular reason I chose this over the fact that I like the way it integrates into the factory look of the dash, and also it does have fairly good reviews and it's known for its reliability and problem-free operation. So this particular Stocklock Extreme unit comes with 3 phases. It has the high speed phase, the low speed phase, and also a low range speed phase as well. And later on I'll go through how to use all of those and how to activate them through the car. So keep in mind this unit is not a gear lock, it is simply a torque converter lock. So it's not going to prevent the vehicle from changing gears or hunting gears if you have that particular issue. So this unit can be easily deactivated just by pressing a button that is put into the dash. Now in addition to that, if there was something to go horribly wrong with the unit, for whatever reason it was flicking up error codes onto your car, you can actually bypass the entire unit with a plug that they add on where this system plugs into the vehicle. So by taking out the plug from the unit itself, plugging in the blanking plate, it's going to bypass the system altogether. Once you clear those fault codes, the unit is not going to be in action and you'll be able to keep going on your way. So what can go wrong with these systems out in the bush, and what are some of the negatives with a lockup kit? So the first one is you've got to remember that these torque converters are put into the vehicle for a reason. They provide a nice smooth drivetrain between that of the load being the engine and the gearbox. So if you are going to be activating these lockup kits at low speeds, they could put excessive lugging, as they call it, or excessive load on the engine at low RPM, and this is going to cause the engine to labour a bit. Now on these particular vehicles that probably will result in some sort of fault code. But you do got to keep in mind at the high speed automatic function, this won't occur. It does lock in at 82 kilometers an hour and unlocks at 78 kilometers an hour, and this means that the engine will never be in those low RPM lugging away. So you got to take in mind if you are going to use the low speed functions, you need to drive the car in a manual mode just to try and keep those RPM above say 1500 to avoid having any error codes pop up onto your screen. Now keep in mind these error codes can be easily wiped just using an OBD 2-port scanner or some sort of computer. But if you are going out bush, it might be something you need to add to your toolbox just in case you were to get one of these codes and put these vehicles into limp mode. Now we're going to jump into the vehicle. I'm going to show you exactly how to activate all these modes and when you would tend to use some of the modes that this particular unit comes with. Okay guys, so we're inside the vehicle now, and now it's time to show you exactly how the unit looks inside the vehicle, how to activate it, and what times and what scenarios to activate the certain modes. So the first thing I'm going to show you is just the standard button that takes up one of the standard blanks in this 200 series Landcruiser. Now one thing you'll notice with the Stocklock Extreme is it is just a single button press. Some of you who might be familiar with the previous versions of the Stocklock lockup kits would know that there are 2 halves to the button. They've got a high and low speed, but the Stocklock Extreme introduces just the single button, and there are different ways to activate the different modes, and we'll go over that now. So guys, let's go over how to activate this kit and how to activate the different modes involved. So first up, let's get the vehicle started. So at the moment the kit is deactivated, and the only way I know that is just by the button is pressed in at the moment. Otherwise there's no dash lights or any sort of warning devices that is going to show you that. In order to activate the unit on the auto high speed unit, you just simply press that button once and the unit is activated. This means that while you're in drive, the vehicle will activate and lock up at 82 kilometers an hour and unlock at 78 kilometers an hour. Now it's quite easy to see when that occurs on the dash, as you can just see the RPM drop at that 82 kilometer mark. Now the reason it drops is because of that fluid type coupling. Your input, which is the engine, is going to be spinning a little bit faster than that of the load, as per the acceleration phase of that torque converter. You'll see that the RPM drop quite suddenly, and that is that connection between the driveline and the gearbox being connected and therefore spinning at the same rates. Again, having it in the auto mode, there are no lights on the dash or any sort of indications that it's activated, but you'll definitely know once you're at those speeds. So in order to activate the low speed mode, which activates at 30 kilometers an hour and unlocks at about 28 kilometers an hour, it's as simple as just putting the vehicle into the sequential mode. So it's pulling it down into drive and then across once. Now you do have to keep in mind, while you're using the vehicle in the low speed mode, you will have to drive the vehicle with the gears. You can't just leave it in sequential fourth, which it automatically defaults to when changing across. If you do that, as soon as it hits 30 kilometers an hour, you're going to drop into fourth gear, and that means the vehicle is going to be put under excessive labor and excessive load, and that is the sort of scenario that's going to cause a fault code to come up on the dash. Therefore, you're going to have to stop and clear that using your OBD scan tool. So just remember to come down to first. You can leave it in second because the kit won't activate until you're in second anyway, just due to the fact that you're going to change into second before 30 kilometers an hour. So just remember, when you're slowing down, you will have to down change from fifth, sixth, or whatever gear you're in, down to second as you come to stationary. Now this kit won't prevent you from driving in the sequential gears if you want to, if that's something that you're used to doing. All you have to do is just press that button, your kit's now not in use, and you can just drive the vehicle as it was when it was standard. Okay, so putting the vehicle back into park. Now the third mode it has is the low range mode. So you're just going to switch your car into low range, obviously selecting neutral there. Low range is now engaged on the vehicle, and you pull it into drive. Again, in order to activate the low range for the lockup kit, which comes in at 8 kilometers an hour and unlocks at 6 kilometers an hour, it's a matter of putting it over into sequential, and again dropping it down into first gear. The same as the low speed function on the higher speeds there at 30 kilometers an hour, you will have to drive the vehicle in manual mode. Now this mode is again designed for steady runs. It's not something you want to be using rock crawling or when you're irregular on the throttle going back and forward. Keeping in mind that torque converter is there for a reason. It's designed to be a bit of a buffer between the engine and the gearbox and provide the gearbox a bit of mechanical sympathy when in harsh terrains. So something like this would be used for a beach run or muddy conditions where you're just going to be steady but in low speeds below 30 kilometers an hour. So we'll get that vehicle back out of low range there and back into park. Now guys, it really is as simple as that for using a lockup kit. One button method, and it's one of the reasons that I chose that Stocklock Extreme. It just is a great unit and it works really well. So now we've learned about how all these systems work and why we fit them to our four-wheel drives, it's time to go out and do some testing. So we're going to hook the caravan up, we're going to head out to the highway, and we're going to do a side-by-side comparison to see some of the benefits that this particular kit brings to my Landcruiser. So let's go and have a look at some of the results from that. So we hit the highway with the caravan to do some testing with the lockup kit. Now for those who don't watch my channel, we do tow a dual axle 2.5 ton pop top caravan, which I do have on the vehicle during this test. Now you can see here from the ultra gauge displays, the left being without the lockup kit activated and the right with the lockup kit activated. The transmission converter and the pan temperatures are significantly lower on the right hand display, being when the lockup kit is activated. And this particular drive was fairly flat, living in the goldfields of WA. I don't have too many hills or inclines around. However, there are a few which did cause the vehicle to downshift and hunt some gears without a lockup kit activated. So I did these runs back to back, so the environmental factors were as close to identical as could be. Now this run was a 90-kilometer round trip back to the service station where I started. Both runs were conducted in identical manners, and both were using the factory's cruise control, sitting at a GPS speed of 100 kilometers an hour. Now that this test is complete, let's jump over to the computer where we can dive deeper into some of these figures we've got. So in order to get a visual representation of some of those data figures that we got from that test run, I've plotted out a graph using every 30-second capture from that testing video. Now I've used the torque converter temperatures, the transmission pan temperatures, the engine temperature and the RPM of some of the figures and baselines that we'll look at today when comparing the before and after that lockup kit activation. So the first thing I'll talk about here is the engine's RPM. So that's measured here by the orange line that we can see going up and down sporadically throughout the test. Now what we can see from that orange line is we can determine which gear the vehicle is in. So towing this van, I was in 5th gear, but we can see here with those changes down to 4th and 3rd represented by an increase in the RPM. So one interesting thing to note, when the lockup kit was not activated, we ended up shifting down to 3rd gear on 12 different occasions. Now, like I said, we just used the factory cruise control, so I let the vehicle determine its own gear selection while trying to maintain a speed of 100 kilometers an hour. Now when we remove the RPM and engine temperature readings, we can see here just the torque converter temperatures and the transmission pan temperatures. Now one thing to note here is we can see an increase in that torque converter every time that vehicle downshifts and the torque converter unlocks from that transmission. The trend that we see from this graph is every time the torque converter spikes, which is when that transmission is unlocked, you get an increase in that transmission pan, but it's not proportionate to the increase in the torque converter temperatures. This happens on almost every occasion, however some are more significant than others depending on how hard the vehicle is working and how long that transmission is unlocked for. Now we can see from that unlock test, we got to a maximum of 115.6 degrees Celsius on the torque converter temperatures and a maximum of 96.9 degrees Celsius in the transmission pan. So now let's have a look at some of the results we got from when the lockup kit was installed and activated through the identical run. So again, I've used the same method of recording, just using the every 30-second capture from that video, and we can see here that this graph looks very different to that without the lockup kit activated. The first thing we note again is that RPM. So we've only got 6 downshifts there, but not only that, it only downshifts to 4th gear. So although the lockup kit is not a gear lock, it has aided in providing more efficient power to the engine, and the engine's decided not to change down to 3rd gear in its automatic mode. Further, when we get rid of that RPM and engine temperature data, we can see here the torque converter and transmission pan temperatures alone. Now this here is a significant difference to that of when the lockup kit was not activated during that run. Now you can see throughout the entire run that these temperatures are almost identical. Now for most of the run, the average was sitting around the 76 degree mark with the occasional fluctuation depending on the terrain we're driving. Now obviously there is one spike in the center, and it is actually when the vehicle is stationary and decelerating where the lockup kit has automatically disengaged due to low speed. We've sat still for a while and that transmission torque converter temperature has increased. Now the last graph we can look at here is a minimum, maximum and average. So you can see here the 2 lines on the left hand side are the torque converter and the transmission temps before, and you can see quite a large spread there between the minimum and the maximum values that we achieved in that first test. Whereas you compare that to the torque converter and transmission temps afterwards, and that spread is very, very small, and the average is generally lower than that of the previous test. So we can use some of these figures here to determine that the average torque converter temp has decreased by 18%. And more significantly, the maximum torque converter temps have decreased by a massive 31% on those identical runs. So there you have it guys, we're back from the highway and you can see there just how much of a difference this lockup kit made to this vehicle, in particular to those temperatures of the automatic transmission fluid. Now during that test I also did a fuel comparison as well. Like I said, it was a 90-kilometer round trip and we started from a service station where we filled the vehicle up on both tests. So the first test here, with the vehicle unlocked in its standard factory format, we got 21.37 litres used. So that is equivalent to 23.7 litres per 100 kilometres. Now doing that exact same route again on the same day in that locked mode with the transmission locked up, we used a 19.47 litres in that 90-kilometre round trip, which there computes to 21.6 litres per 100 kilometres. So there we did get a 2.1 litre per 100 kilometre fuel saving, which is equivalent to 9%. So in my books that's quite significant, and over a long period of time that is definitely going to save some money and some fuel bills. So guys, there you have it. That is my review on the Stocklock Extreme unit and why I fitted one to my vehicle. So is it something that you need to fit to your car? Well, that is just going to depend on what you use your vehicle for, how it's modified and whether or not you tow. If you're someone like me who likes to tow a van, tow a heavy load, put some bigger tires on, load your car up for a camping trip, then absolutely it's something that I would recommend. It's going to significantly reduce your automatic transmission fluid, which is going to provide safety benefits to your transmission, a long life, and prevent you having to change the oil and do flushes all the time. It's going to improve your fuel economy, and it's going to make sure it's a nice comfortable ride when you're out on the highway. We saw from that caravan testing there just how fewer times it switched down to a lower gear, not even touching third gear at all, like it did 12 times on that first test. Overall, I've done a few thousand K in this vehicle now with it fitted, and I'm extremely happy with the way it works. It's throwing up no fault codes, I've had no issues with it, and hopefully that will run into the future problem free. So guys, if you have any questions about any of the things we talked about today, any of the topics I mentioned, make sure to hit us up on Facebook or Instagram at Exploring Oz. I'll be more than happy to get back to you and answer any questions you might have. Otherwise guys, I appreciate you watching, and we'll see you in the next video. Thank you.